Hello and welcome to the observability track at the What the Fuck is SRE conference 2022. Today I'd like to welcome you guys to our track. If this is the first time that you're joining us on the observability track, please remember we do have a COC for our events. My lovely co-host Sebi will drop it into the channel. And also please remember to stop by the booth and visit our amazing sponsors for the event. They are Blameless, Cortex, Stormforge, Teleport, Lightstep, Fire Hydrant, PagerDuty, Rootly, and Shoreline. And without any further ado, I'd like to introduce our speakers for the day. They are Ramiro, Álvaro, and César from Empathy and Kayak. They are going to be talking us through cloud FinOps and sustainability on Kubernetes. And without any further ado, I will hand over to the team.
Hi, how is it going, guys? We are so happy to participate in this What the Fuck is SRE 2022. I hope you are enjoying this event, and we'll try to give you some ideas about how to adopt Cloud FinOps on your Kubernetes cluster. But first of all, I'm not alone in this talk. César and Álvaro are going to help me to show us what cool stuff is FinOps. We are so passionate guys, and we love to try new trends. And as soon as we read about FinOps, we start falling in love with the concepts and the culture. Then we push to embrace this culture on our companies. The agenda for today will be, first, we are going to give you a little bit of context about what the fuck is FinOps to understand better the motivation of this talk. That I'm going to do a little bit of spoiler, that is create a Kubernetes cost report to bring visibility to teams and explore the architecture and the future of this solution adopted, and to finish, to sum up with some takeaways and a questions and answer sections. As DevOps revolutionized development by breaking down silos and increasing agility, FinOps increased the business value of cloud by bringing together technology, business, and finance professionals with a new set of processes and culture. As you can see, all teams have a word in FinOps, from finance to exec, platform, product teams. All the teams have different motivators that drive spend and savings. And teams in every organization needs to work together with a balance of empathy for one another goals. Basically, FinOps help align teams to organizational goals. These all looks pretty good over the slides, but how can we start? FinOps lifecycle can be reduced to 3 phases. From 0 to hero, the first phase will be the info phase, where the focus will be increase the visibility and allocation of the cost resources. To getting started, defining a task allocation strategy will be key to have a common language between teams. After the first phase, we can walk through the optimization phase, where we can save costs easily by cutting down the resources on the underutilization workloads, for instance. And the final step, the more mature phase, is the operative phase that focus in the automation and spread the culture around the company. On our journey, we found out that the vast majority of the cloud provider has a report to review the cost, but there is no way to explore Kubernetes workloads cost from our cloud provider. Therefore, we try to do it. Why not? The goal of the Kubernetes cost report is to facilitate teams a new visibility layer regarding workloads costs. Then, to sum up, the motivation. Yeah, the motivation, this guy in bicycle. The motivation is to offer cost visibility to the teams, besides giving them the possibility to see the impact of their actions. What happened when they upscale a resource? What happened when they downscale a resource? Or what if they forgot to delete a resource that is spending $1,000 per month? And all this together with a near real-time feedback to provide metric-driven cost optimization that we are not going to spend a couple of days to ask. Although there are some third-party alternatives, the vast majority has an expensive license cost, and well, the report is not precise enough. Therefore, we are happy to share our links for these. Our North Pole for this talk. That is the link for our Kubernetes cost report open source project and the link for the Grafana dashboards where you can contribute, use it, review it. Maybe you are going to get some inspiration on these links. Now, our master and commander, César, is going to show us the architecture of this solution. César, all yours.
Didn't find anything in the market that fulfill our requirements, so I will have to create one. So we have to create one. We didn't want to reinvent the wheel, so we have reused some part of our current infrastructure to do the job. So here you have a high-level diagram how the system works. So we have a Golang service that get the prices from the cloud provider and then we have Prometheus that scrap these metrics and combine that metrics with other metrics from the Kubernetes API, and with some recording rules will transform the data that later on we can visualize with Grafana, where our developers and product managers can check the cost of our workloads. Before I go deeper into the what the exporter does, let me explain you two concepts. First is the machine types. The machine types represents or defines how many the resources that a VM has. So, for example, in the Amazon Web Services Cloud, you have the M6i that represents a machine that has 2 CPUs and 8 gigabytes. There are tons of different machine types, and they are divided in several families. And it could be the possibility that one machine type has the same resources, 2 different machine types that's the same resources but different prices. Another thing is the instance type. The instance types. The instance types are how the cloud provider is tariffs the VM. And for one hand, we have the on-demand instance type, where we know on front the amount of money that we are going to pay for a machine for a given time. Meanwhile, we have, and in the other hand, we have the spots. The spot instances, the price of the spot instances vary depending on the availability zones that they are running, and it's also changed during time. So now that we have these two things, let's go deeper into the exporter. So the exporter is a Go application that runs as a deployment in our Kubernetes cluster. We have provided all the necessary Terraform scripts to configure the IAM roles so the service can retrieve information from the cloud provider. And we also provide a Helm chart that allow ICE installation and a nice integration with the Kubernetes stack. So the exporter retrieves this information, as I said before, from the cloud provider and transform the data in several metrics. So the most important one are the instance code that represent the price of a given machine type, the instance CPU price that represent the price of one CPU for this machine type, and the instance main price that represent 1 gigabyte of the price of 1 gigabyte of the same machine types. This metric has several combination of Prometheus labels depending on the instance type. So, for example, we will have the combination for the on-demand instance price and also for the spot. For the spot, we also will have one per availability zone where the spot instance can run. And now that we have this granular price information, we can calculate how much the cost of our workloads is. So Álvaro will explain this part to you.
So now it's my turn to talk about taxonomy, okay, which is just a classification of cost, okay? We want to know how much our workloads cost, because money is something simple to convey, but we specifically want to know what is the cost, I mean, in what workloads are you spending more money, in what resources. Okay, so in order to try to explain to you what we are calculating and how we are dividing those costs, a small analogy will be like we want to build a deposit of water, for example, to serve water to different individuals. Okay, so the simple case is we just go ahead and we ask every individual how many gallons of water do you need. Okay, and then one individual says 103 gallons, the other one says 3. So we say, okay, 103 plus 3, that's 6. Then we put one extra there available for everyone to use. So 107 gallons, right? This extra available is to accommodate for bursts or spikes in demand or whatever. Like, I don't know, if you get home one day, you're covered in mud because you've been playing soccer or whatever, and you need a little bit more. We can accommodate for that. And we have to pay for those 107 gallons of water. Also, when we get our bill, there's something else in there, right? Like we had to pay for methane equipment. We had to pay for being connected to the main distribution system. And those are costs that we cannot relate to a given individual. It's something that is shared among all of them just to have access to water. So that's kind of a shared cost. And then when we take a closer look, sometimes we can realize that, okay, one individual is requesting 103 gallons of water, and we have to guarantee that it is in our deposit. But then maybe that individual is only using 3. And there's a difference of 100 gallons that we have to guarantee is there in our deposit, and nobody else can use. It's only for that individual, okay? And it's idle, something that is idle, are resources that are idle are not being actively used, but we have to make sure are there and nobody else can use them, which is different from what is available to accommodate bursts or spikes or whatever, right? So that's the main idea of underutilization, that difference between what is being requested and what is being used. So when we think about Kubernetes, instead of having one deposit, we just have several deposits, right? That's our cluster, those are our nodes in our cluster. And some are bigger, some are smaller, especially in the cloud. We have different virtual machines, different sizes. And instead of serving directly individuals, we serve to households. And households will be like logical aggregation of individuals, if you want. And those households have namespaces in Kubernetes, and the individuals will be pods in Kubernetes, right? So we can apply the same logic at the different levels. We can go still at the individual level, at the pod level, and say, okay, how many resources are you using? Are you requesting from us? And we have to guarantee that this is in our cluster. If there's a difference, there will be some underutilization. We can apply that same logic at the household level, and we can apply that same logic at the cluster level. We should not forget about our share cost, that in the cloud, we have to spend some money just to spin up a cluster, like to have access to water. We also have to keep that in mind. And that's our taxonomy right there. I mean, there's nothing more to it, okay? We want to know how much we are spending in use resources, actually use resources, how much we are spending in resources that are requested from us, and we have to guarantee are there. If there is a difference, we know there is some resources that are underutilized because we are guaranteeing that those resources are there, but the individual or the workload that can use them is not using them, and nobody else can use them. Okay, then we may have some available resources for everyone to use whenever they need it. So that's okay, and we want to have a little bit of that. And those resources will be idle, but with the big difference that something that is available for everyone is something we may want to accommodate these spikes, but something that is idle because it's underutilized and nobody can use, that's not something we want, right? And also the share cost, right? That we have to pay something for the as a spin out the cluster there. So we're calculating two main types of resources, CPU, memory, and also persistent volumes or disk in Kubernetes, okay? So if we can calculate the resources and we can get the prices of the different resources, like César has explained before, we can get some dashboards, right? And the whole point of those dashboards is to give visibility to the cost of these workloads in Kubernetes, okay? And we want that in near real time. So we have a feedback loop that is faster than so many cases the cloud, because these cost reports from some clouds take some time, maybe in the order of days, and we want to have almost near real-time feedback. And we decided to make this code open source so everybody can use it and break it and do whatever they want with it, right? And that's the idea. So to give you a glimpse of the dashboards we have prepared, first of all, sorry, a disclaimer. I mean, don't pay too much attention to the numbers. The numbers are fake. This is something we spin up for the occasion. So the numbers that don't really, the exact number don't really mean anything. Okay, it's just for example. But what we want to focus is we can calculate, we can give you what is the total cost of the cluster, how much we are spending in idle resources that are not being actively used, but divided by what is, okay, it's not being actively used, but it's available for everyone to use to accommodate for these spikes or bursts. How much we are spending in underutilized resources that someone has requested, is not using, and nobody else can use. This is kind of hoarding, if you allow me that word, right? Then how much we are spending in actual usage resources, how much we are spending in this share cost, how much we have to pay to spin up our cluster, and how much we are paying in persistence, okay? So we can go far down and divide these costs by instance type, capacity types, as I have explained about this, right? To get, okay, what's the instance type that is better for us? We can have the evolution over time, and we can present the same cost just at namespace level, this logical aggregation of workloads at the pod level to have the exact workload. So that's something it's available for everyone to see. So if you want some more, the idea here is, okay, so in order to calculate this cost, we already have to calculate the resources, right? We've gone through that. So why don't we focus on the usage report? It makes sense. And with a special focus on this underutilization, because if we want to decide if we have to delete a workload or we have to right size it, like fit it to the needs, to the actual needs, or we just the architecture and all the stack, and we just move it to Kubernetes and we realize it's spending too much. It's easy to talk about CPU and memory and persistence than just dollars or costs that is difficult to work with, right? So we also have some of that if you need it. So you can have some dashboards where you can see what's the underutilization or the unused CPU, memory, or persistence. Okay, we can get the idea of what resources are actually setting the requests or are leaving just unavailable resources, which workloads are setting the limits, the usage they have is limited, even what quality of service the workloads have in the Kubernetes cluster, which is something we may be interested in. For different clusters or environments, we may want different quality of service. And we can also give some recommendations, like, okay, how should we set these resources in our cluster? That both for CPU, for memory, for persistence, maybe we are just underutilization and we want to right size, right? So now that the end is, we are getting closer to the end, what we plan to do for the future is, okay, we have all this visibility, which is nice, but still we would like to track these kind of things and get some kind of reporting or something like that, right? So we want to track and to see the evolution over time. Also in sustainability, because now some clouds are starting to report what's the carbon footprint of the resources or the services they provide us. So if we already have the resources and we can query the cloud for what's the carbon footprint of the resources, we can calculate the carbon footprint of our workloads, right? So we can focus in something even more important than just money, is the sustainability of our plan, right? And as a real next step, like what we plan to do next is focus a little bit on spot or preventable capacity of instance machines, because that's a little bit tricky to calculate. And we are doing it per hour right now. So we would like to go down even to by a minute calculation. So tune a little bit more those preventable or spot behavior. Okay. So, and as main takeaways for this presentation, what we want to convey here is that we've been working, and we hope this is helpful for everyone, in a cost report allocation for Kubernetes, so we can bring cost visibility to our workloads, highlighting trust, sustainability, transparency, something that is accessible and that gives this information in a timely manner. And we want to make informed decisions, right? So these decisions that should be driven by the business value of the cloud, and we need to get the information in order to make informed decisions, and also to bring cloud cost ownership, because to an organization, I mean, a team or a squad or whatever you have in your organization or company can take ownership of their cloud usage and understand what they are using and how much we are paying for that. So as we said, this is open source. So you have here the GitHub repository where you can find all the code. All the dashboards are uploaded to grafana.com. So feel free to use them, break it, report as many bugs as you can, everything you want to do with it. And that's the real end of the presentation. So thank you very much for your attention, and I hope you enjoy the talk. And we are open to questions.
Thank you, Álvaro, and César and Ramiro. I'd like to yes, read this question from our Q&A section to you. What is the recommendation to take actions based on this report? Should it be only factor to look into the cluster usage? This is from Pravesh.
Could you repeat the question?
Sure. Yeah, what is the recommendation to take actions based on this report?
Oh, okay. The main idea is to maybe, I think, for instance, a new project starts, and usually when a new project starts, you don't know the limits, and you have to put a big effort, and you are going to spend a lot of money. But once your product or your project is mature, you know better the workload usage. Therefore, you can adjust the limits and the request. Therefore, for instance, you are going to start a project and you are going to overuse 50% of the resources. Our recommendation, that is something that we found out at our companies, is to go step by step and try to reduce the 50% of underutilization to 25% of underutilization. And once you are going to get the 25% of underutilization, try to cut down a little bit more, just to have room for a space. Maybe a 10% of underutilization is good enough for your workload. It depends of the expectation, traffic expectation, and the scalability of your workload. But I think that it should be little by little, step by step. Maybe you are going to, it's going to be a huge step from 50% of underutilization to 25%.
Okay, thank you. Yeah, the second part of this question was, should it be only a factor to look into the cluster usage?
Well, to be honest, it's not it's not only the cluster usage, it's the workload usage, to be more precise, because it's not the 25 for your total cluster, it's the 25 of your workload requests and limits that you set in your deployment or in your stateful set.
Okay. Thank you.
Yeah, this is more about the underutilization of this workload. We know that this is not perfect. This is a fairly approximate idea. And maybe you are going to have some workloads that, for instance, keep to my mind some databases that the database, the data set is safe on memory. Maybe you are going to have an underutilization of 50%, but in the real nature of the data of the database is not the 50%, and is because you need the RAM to cache all the data.
Okay. Yes, I have two more here. What other tools can be used for Kubernetes cost report in place of shown in the architecture?
So right now, I don't know if the question refers to that. We only can use Prometheus and Grafana for that because the integration is really tight and how we expose the metrics. So there is only these two pieces that can be used for that.
Do you plan to maybe expand the tool set?
I don't think so because it's really tight how the architecture is done. We need something that scrapes these metrics, and also the recording rules are only used by Prometheus, so it will be difficult to change to other data source. Maybe in the future we can do with something with Influx, but we are not sure.
Okay, thank you, César. And does Cost Explorer work only on AWS cloud or other major clouds as well?
So right now, only in Amazon, we have plans to do it also for GCP because we also have some our infra there. So let's wait a little bit, and probably we will have a release with the GCP. Yeah. And on the future, maybe Azure, but we are not sure. If somebody wants to do it, we are open to receive a pull request.
Okay.
We hope to expand
questions are coming in. So one more from Martin. Can you share again the links to the GitHub and the Grafana dashboard that were shown?
Yeah, sure.
Maybe I could put it in the comments for you if you share it with me. Yeah, thanks again, Álvaro, Ramiro, and César. It was great to listen from you guys. So this was our second talk on the observability track of what the fuck is SRE 2022. So we'll have a short break now. In the meantime, please don't forget to check out the Expo tab to visit our sponsors booth. Our sponsors are Blameless, Stormforge, Teleport, Cortex, Shoreline, Lightstep, PagerDuty, Fire Hydrant, and Rootly. And in the People tab, you can reach out to other attendees and speakers with a direct message. If you have any questions, you could find our speakers there, or you could just find them on Twitter, I assume. And please use this opportunity to mingle with this amazing audience today here. And keep in mind that we have a code of conduct we all need you to follow. So that was it. Thank you, and hope to see you very soon.